Let us go through dimensional analysis. So, in this lesson, we're going to talk about the basics of dimensional analysis, everything you need to know. And then, in a separate video, we're going to deal with the tutorial sheet answering questions. So, we can get started with it. So these are the things which we'll look at. So to begin with, what is dimensional analysis? So dimensional analysis is simply where we investigate the relationship. So where we investigate the relationship between different physical quantities. What are these physical quantities? We have length. Length is a physical quantity represented by letter L. We have mass represented by M, and we have money. Yeah. So this is the other physical quantity. So remember, time is money. So time is the third physical quantity, which is represented by letter T. Okay, so we're done with the introduction. And what are the uses of dimensional analysis? So we use dimensional analysis to derive an equation. Now we can use it to derive an equation. We can use dimensional analysis to check if an equation is correct. We can use dimensional analysis to check if an equation is dimensionally correct. Yeah. So those are the uses of dimensional analysis. We are done. This is going well. How to determine, are you able to see these? So how to determine the unit of a quantity? Okay, so here we'll spend at least 3 minutes or even 5. So how to determine the units of a quantity? So this is quite basic. So how you determine, for example, let's say we have speed is equal to distance. Speed is equal to distance over time. Everyone knows. And then they tell you that, can you find the units for time? Okay, and units for time, you already know that it's seconds, but they just want you to show that you know how it is like that. So here, when we're given something like this, we just have to make the quantity which we have been asked, we have to make it the subject of the formula. Yeah, so before we even find the units for time, I would just like to have a quick side lesson. So under the laws of indices, we learned that if you have something like this, 1 over a power 3, you can get rid of the fraction, meaning you just write a power 3, but the power should have a negative. Yeah, so that's how you get rid of the fraction. So you can have b over c power 5. Maybe b is power 2. So to get rid of the fraction, you are just going to say, okay, I write my b squared, and then I also write my c squared. But since c was down, it should have a negative. Yeah, so I hope we're together on that. So in the same way, you can also work backwards. If we have b squared and c power negative 5, when you just see a negative power, just know that okay, then I have a fraction. The thing which has a negative power should be down, and whatever doesn't have a negative power should be on top. Yeah, so we get back to finding the units for time. So what you do here, you just basically say, we make time the subject to the formula, meaning we're going to have time is equal to distance distance. Oh, and by the way, I don't know why people get offended. People who are in love, those who are in long distance relationships. So when they just hear the word distance, they feel bad. Like, why is he talking about distance? I'm very sorry. Don't worry. Very soon, you'll be together and you'll be happy. Like, yeah. Mwah. So we proceed. Let's not make the people cry who are in long distance relationships. So, time is equal to distance over speed. Distance, what are the units for distance? They are meters. Over speed, what are the units for speed? They are meters per second. Okay. It's going okay. So this is m. We can rewrite this as, we just write it as a fraction. So remember, as a division symbol. So division, a fraction simply means division. So m over s, meters per second. This simply means over. Yeah, and then from here, we just say this will be m times, so when this becomes times, this will be s over m, and then we can cancel this, cancel that, so this will be s. So these are the units for time. You see, easy peasy. So that's how you find the units, how to determine the unit of a physical quantity. We are done. This is going so well. So before we go to the other thing, I can give you some work which you can do. Okay, so this is the work which you can try to do. So by the way, this is coming from the Megaminds document. Yeah, so all these have been explained in document form. You can check out the tutorial sheet which is at the end with solutions explained and also the rare concept. So we'll quickly go through this one together. So force is equal to GMM over R. Okay, so this is just the Newton's law of gravity. Yeah, so and we're going to do this topic it's ahead. Yeah, so we have been given, I'm sure you have read all these. So this is the force, gravity, mass and mass, and we have R. So R is supposed to have a square. So this is the separation distance between the two masses. So now the question is, find the units for G. Find the units for the gravitational constant. So you just make G the subject of the formula. So when you cross multiply G times 1 here, it is those same things, GMM. And then here we have for real FR. And then to remain with G alone, we say over M. Over M and M, even here over M and M. So what we get is G is equal to F R squared over M and M. Okay, so at this point now we can find the units for G. Yeah, so we'll just say this will be equal to, so what are the units for force? So the units for force, we have newtons times the units for r, the radius, it is the distance. The units for r, it is m, meters, and then it is having a power 2, over the units for m and m, it is kg. So I have kg and kg. So this will become nm squared over kg squared. kg times kg. Yeah, so these are the units for the gravitational constant. And then remember, if we want to get rid of the fraction here, we just make the power of the denominator to be negative. So meaning the units for gravity or gravitational constant, they are n m squared kg power negative 2. Yeah, so that's how you do it. You see, almost no thinking. So can I give you an exercise now? Yeah, so try this. Let's say we're going to say what? Initial velocity. So this is initial velocity minus final velocity plus acceleration times time is equal to 0. Can you find the units for acceleration? Now what are you going to get? So you can show me your work and then we see what you get. So just follow the same thing. So if you've understood how to find the units, you can like the video. So now we have introduced the uses of dimensional analysis, how to determine. Okay, we're done with that. So how can we determine that an equation is dimensionally correct? Okay. So for us to determine whether an equation is dimensionally correct, we just consider, for example, let's say force is equal to mass times acceleration. If we want to determine whether this equation is dimensionally correct, we have to look at the units on the left hand side here, and also we have to consider what we have on the right hand side. Yeah, so we're going to do that in a bit. Yeah, just within a minute. But before we can go there, first let me just explain on dimensions. So dimensions are these things which you can see here. So what are dimensions? Dimensions, they are basically a representation of a physical quantity. We already said length. We said length, the symbol is L. Mass, it is M, and money, it is T. Yeah. So but don't say money in class, they are going to chase you. So time there. So and then now if you want to write it as dimensions, as a dimension, it means this becomes, we put it in brackets. Yeah. So mass as a dimension, we just write it like this. Even this, we write it like that. These are dimensions. So now how do you prove that an equation is dimensionally correct? Let's have an example. Okay, so this is just a set of questions here. So there's another video where we were answering these questions on top. Yeah, how to convert 25 miles per gallon into liters per 100 kilometers. You can check that out. So now here we just want to deal with dimensional analysis. So this one we have already answered. We have found the units for G. So we're done with this. And then I want to answer this one. All the questions are simple and nice. Yeah, so before we go to, so we're about to start proving that an equation is dimensionally correct. But before we prove, I would like us to go through something like this, what we have here. Yeah, so let's go through this question and then we'll proceed. Okay, so where is the question? Okay. So this is our question here. We want to find the dimensions of B. Yeah, so this is how questions can come. So the same way I taught you how to find here. So this is a very simple example. You can even understand if you are asleep. Speed is equal to distance over time. You remember, if you want to find the units for time, you just make time the subject. If you want to find the units for distance, we just make distance the subject. Yeah, so at this point we're now talking about dimensions. So we're now talking about dimensions. First, how to find dimensions, and then we'll also prove whether an equation is dimensionally correct. So now let's see how to find dimensions. So we have a case here where we have been told that x is equal to b t squared, and the question is, what are the dimensions of b? What are the dimensions of b here? Okay, so we'll just say, for us to know the dimensions of b, we make b the subject of the formula, meaning we divide by t, and b will be equal to x over t squared. Yeah, so this has just cancelled. We have x over t squared. Yeah, and then from here we just substitute with the units. So what are we going to have? So x is what? So x is the displacement. So they say, suppose the displacement of an object, this one. So the displacement of an object, x is equal to bt. So x is the displacement, meaning you know that x is the distance. Yeah, so x is distance, like that. And then t is time, you already know. Yeah, so from here, and it's going to have a square. So what is the SI unit for distance, displacement? We just say it's meters over time, it's seconds, and it has a power 2. So if the question said find the units, we could have said, okay, these are the units, and then we even write it as meters per second squared, or we even write it as meters per second squared, like that, -2. So the question didn't say find the units, it said find the dimensions. So we have to find the dimensions here. So always know this is length, meters is length. So the dimensions for meters, they are L, this is the length, over seconds, that's time. So you can see the dimension analysis is coming up. Yeah, so we're done like this, and then we even leave it in standard form. So the standard is that you should have no fraction. Yeah, so this is how you find the dimensions. Easy peasy. And then from here, what else can we do? There's another question which I don't want to do. So this one. Okay, so what if x is equal to a sine 2 pi? So this is a formula under simple harmonic motion. So as you are studying your A levels, your natural sciences, later on when you reach to simple harmonic motion, you are going to find my videos again. They are already there. I made them some time back. So now this is an equation for displacement in simple harmonic motion. So they want us to find the dimensions of what? Find the dimensions of A. Okay, this one A. Okay, so and then they have told us that trig functions, they are dimensionless, meaning they do not add value to dimension analysis. So we can ignore wherever there's trigonometry. So sine, we're going to ignore it. And also numbers like 2, we do not consider them under dimension analysis. So we're going to ignore sine, we're also going to ignore 2 and pi. Pi is just a number, 3.1419 is going on and on. So we will ignore sine and 2 pi. So we're just going to remain with ft. This is the solution coming up. And then we can make a the subject of the formula. So here we divide by ft, also there ft. So this means that a will be x over ft. Yeah, so this cancelled with that. So we've made a the subject of the formula. When you just do that, then you even put the units. So a is equal to x. X is the displacement. So the displacement, you know, it is meters, over f is the frequency. Frequency, it is the number of oscillations made in 1 second. The units are hertz. These are the units for frequency, hertz, but that's not the SI unit. If you want to write it as an SI unit, the units for frequency as an SI unit is 1 over S. Yeah, so where there is frequency, we put 1 over S times time. The units for time, they are just seconds. Okay, so we can simplify the denominator. So on the denominator, we just have 1 over S times S. You can see here that these two, they will cancel. So, and the final answer is just S is equal to M. Yeah, so we've found the dimensions. So you've gotten how to find dimensions. Are we good? If you haven't yet liked the video, you can now like it because you've understood. Give Caesar what belongs to Caesar, and give Mega what belongs to Mega. So we have done dimensions. Now let's do let's prove that an equation is dimensionally correct. So again, we'll go back to that tutorial sheet. So unfortunately, these questions, I actually solved them in the Megaminds document. Oh, by the way, the Megaminds document is even here. So it has the tutorial sheet at the far end. We have uncertainty measurements there. So yeah, so this is the tutorial sheet. It's not so clear here maybe, but on your phone you'll be able to see everything nicely. So if we've just answered this one, but from answering how to find the dimensions of B, we've also found the dimensions of A. Yeah, so these are more practice questions just for you. So here the question was to prove that these are dimensionally correct. Yeah, and some more practice questions. So these were the solutions. So the dimensions, oh, I even forgot there. I just ended on M. Yeah, so M, these are the units, but the question was find the dimensions. So the dimensions for length, they are meters. Okay, so I kept forgetting. Yeah, so when solving this one, I forgot a power 2. Yeah, so at least we have the document where I was relaxed. Yeah, so for that question, if we had b is equal to x over t, then the dimensions will just be what we found. Yeah, was it L? Yeah, LT. Yeah, we had found LT. So, but if you put a square, meaning also t, we'll have a square. Yeah, so now let's practice more. Yeah, so remember, practice makes perfect. The more you practice, the more you even remember in your exam that, okay, here I made a mistake. So now like this question was answered in the document. So let's go through this one. For a simple pendulum, they want us to prove that this equation is dimensionally consistent. Okay, so dimensionally consistent, just the same as saying dimensionally correct. Yeah, so I have a number of examples. Yeah, so I'm just going to answer this one. So even this is in the document, so I'm feeling lazy a little bit, sorry. So let's go through, let's find the dimensions of period. So they have given us that period is equal to what? It's equal to 2 pi. So period is equal to 2 pi square root of L over T. Oh, okay. So how to prove that an equation is dimensionally correct? I said you have to consider the left hand side, and you should also look at the right hand side. Yeah, so for the left hand side, what do we have? On the left hand side we have time. Oh, this is period, sorry. So this is period, and what are the units for period? So starting with the left hand side, the units for period, they are seconds. So meaning on the left we have seconds, and the dimensions for time, you know, it is t. Yeah, so that's what we have on the left. So if on the left hand side we had like t and anything else, like maybe also v velocity, meaning and then now we can go to the right hand side. So the right hand side, this is where we have some work. So we have 2 pi. Remember, when we have a constant, we ignore it. Yeah, so we're going to ignore 2. Also this one, we have 3. We have 3.142. So this one, we're going to ignore it. Yeah, pi is just a number. So meaning what is left is just square root over L over G. So we're going to check if on the right hand side, are we going to end up with this? If we're going to end up with the same thing, then we'll say the equation is dimensionally correct. So we start. So we have square root. So length, whatever. Oh yeah. So length, L length, it is the dimensions for length, it's meters. So let's put meters where we have length. So length, it's meters, meaning the dimensions are L over gravity. The units for gravity are meters per second squared. So meaning in dimensions it will be L over T squared. So L over T squared. So remember, to get rid of this fraction, the power should be negative like that. Okay, and then from here we can just cancel. You can see we have L and L, meaning we'll remain with square root over, on top we'll just remain with 1 over T negative 2. And then from here, what are we going to say? Yeah, so from here, okay, so then so here we have 2 ways of how we can further simplify this. So according to the rules of indices, we can also just swap, like in this case 1 will just come down, this will be t over 1, and the negative power will go away. it will just remain like that. So meaning will just remain with t squared. So but just in case you have forgotten the rules of indices, so here let's redo this. I cancelled 2 early, so before we can even cancel, let's just write it step by step. So we're going to say this is L over t. We have L over t squared. So now at this point we're going to say square root over, we have L, so this, it will change to division. Yeah, so let's change to division. So we're going to have L divided by L over t. So L over t, like t squared, like that. And then we'll go on to say square root of L. So this will be times. So meaning we'll have t squared over L. Oh. So from here we can see that something is cancelling. So this L, it will cancel with that L, meaning the thing which we're remaining with is just t. So we have t squared, and then the square root can cancel with this square. So this and that will cancel, meaning we'll just remain with t. Yeah, so this is how we've proved. So, and then you even conclude. You conclude to say that therefore, since left hand side is equal to right hand side, then the equation is dimensionally correct. Yeah, so that's how you go about proving that an equation is dimensionally correct. We have done this. Yeah, so now from here, this is where we end. In the other videos now, we're going to in the next video after this one, we'll deal more with now deriving an equation using dimensional analysis. So I have a number of practice questions here. Yeah, so we'll derive and proceed just like that. So see you in the next video.